We are continuing with the solving of the various reaction-based questions in the previous year's papers. And in this video, we will be discussing about the set-2 2020 question paper. And I've gotten this from the iitnacademy.com. Do check out their website. They have question papers for other subjects as well. So let's start with question number 37, which is the only one for this paper. So 37A. So in this question, we've been given, we have to figure out what a particular compound is, that is the C5H10O. And they've given us certain pieces of information regarding this particular compound. And what we are going to do is we're going to write down what the information that has been given and then go through it. And I will tell you the reasoning for each and every decision that has been made to solve this question. So let's start with this. An organic compound A having the molecular formula C5H10O gives negative tolerance tests, forms N-pentane on Clemenson's reduction, but doesn't give an iodoform test. Identify A and give all the reactions involved. Now, looking at this question, it feels like there's so much information, and it might be, in a very stressful situation, like an exam hall, for some people, i.e. me, I found it difficult to solve these questions as they are. So what I would do is I would break them down into smaller bits and pieces of information and then solve or understand each and every bit and piece and then figure out the answer. So we're going to do the same for this video. So we have an organic compound A, we don't know what it is, and its molecular formula is C5H10O. Okay, now it is giving us a negative tolerance test. So negative tolerance test. Writing that down. The next one they say is that it gives us N-pentane. Now, N-pentane is an alkane. Alkane having 5 carbon atoms. So CnH2n plus 2. So C5 and H5 is 10 plus 2, that is 12. And this is the product on Clemenson's reduction. Okay, but it does not give us, so it does not undergo a chemical reaction, or it doesn't give us a positive iodoform test. So this is what has been given, and we need to figure out what this molecule A is. Now, okay, so we have C5H10O. First of all, it cannot be an aldehyde, an alcohol, because an alcohol, okay, let's take 5 carbon atoms, 3, 4, 5, okay, and I don't care about the position, but OH, okay, and then CH3, H2, 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 H2. So 2, 4, 6, 8, 9, 10, 11, 12. Oh, wait, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. The 12 carbon atoms. And even if it was an ether, this hydrogen OH would have shifted, and then we would have had a CH3. So it's not an alcohol or an ether. And another easier way to figure that bit out would have been the fact that this particular compound has given us a negative tolerance test. And so this particular compound can either be an aldehyde or a ketone. So we have 2 possibilities. Now, the fact that it has given us a negative tolerance test implies that it is not an aldehyde, but it is a ketone, because aldehydes would have given us a positive tolerance test. The next piece of information is that it gives us a C5H12 on Clemenson's reduction. So what has happened is, so this is a basic chemical reaction of Clemenson's reduction, where a carbonyl compound on reaction with zinc amalgam in the presence of HCl leads to the formation of an alkane and water. So our compound C5H10O on reaction with zinc amalgam and HCl has given us C5H12 plus H2O. Now what I'm going to do is I'm going to open the structure up, which is CH3, CH2, 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 CH3. So this is our structure: 1, 2, 3, 4, and 5. 5 carbon atoms. Now let's number this first. So 1, 2, 3, 4, 5. And since it's an alkane, I can just go from here to here, or I can do it from here to here. Now, our possibilities of the carbonyl, the CO, the carbonyl carbon, which carbon atoms are going to give us out. So first of all, the first position and the fifth position cannot be considered, because if the carbon was this one or this one, it would have been an aldehyde and not a ketone. The next one is either two. Oh, let me shift back to black. Okay, the next one is going to be 2, 3, or 4. Now, the reason we need not consider all the 3, but just 2 or 3 is that when you think about it, if you, let me just write it at the second and the fourth position. And I think that immediately would help you understand why I'm not considering both of them. So this is when it's at the second position. Next is going to be at the fourth position. So CH3, CH2, CH2, CO, CH3. Okay, now here you have a methyl group, you have a methyl group. Then you have a propyl group, you have a propyl group. So essentially they are the same compound. IUPAC naming wise, we would name it 2-on. This would also be 2-on. Because of that, we're not considering the fourth one, but just the second carbon atom. So let me just erase this. Oops. That's right. The next one is the third carbon atom. So CH3, CH2, CO, CH2, and another CH3. Now, it can either be this or this. Both seem correct, because based on whatever we figured out, both of these would not give us a positive, it wouldn't react with Tollens reagent to give us a positive Tollens test, and it would give us N-pentane on reaction or on Clemenson's reduction. The last one, the last piece of information is that it does not give the iodoform test. Now, an iodoform test for a chemical or for a compound, for us to give a positive iodoform test, it would have to have a methyl group. So the second this number 2 would have given us a positive iodoform, whereas this, it does not react or does not form the iodoform, or does not react the iodoform test, or does not give us a positive answer for the iodoform test, whichever. But because it does not, this is the compound. Okay, now they've also they've asked us to identify A, which is spent 2-on. So the A is spent 2, I'm sorry, spent 3-on. And the next one is they've asked us to give the reactions involved, and the only reaction that I can see that has been or has occurred is the Clemenson reduction. So I'm going to quickly write that too. So Clemenson's reduction is CH3, CH2, CO, CH2, CH3. This is spent 3-on, reacts with zinc, amalgam, and HCl to give us CH3, CH2, 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 CH3 plus H2O, water. So with that, we're done with this question. Let's move on to the next one. We are supposed to carry out these conversions. So let's start with the first one. That is, we're supposed to convert propanoic acid to 2-bromopropanoic acid. So that is CH3, CH2, COOH gives rise to CH3, CH, COOH, and a 2-bromo because COOH is the primary group. Bromine gets, so this becomes 1, this is 2. So 2-bromopropanoic acid. So we have to convert this to this. But before I explain all of that, there's something very small and minute that I just realized when I was writing this reaction, or when I was writing the structures for this. It took me a second, or it just took me a second to write the formula for propanoic acid. I don't know if everybody tends to do this or is it just me, but what happens is when I consider this, I consider only these carbon atoms, which is wrong, absolutely wrong. It is 1, 2, and 3, and that's why it's propanoic acid. So after all of that happened, I started referencing it to acetic acid. Acetic acid is CH3COOH, and somehow I managed to remember that always, and it was very easy for me to remember that. So I would suggest, if you are looking for a way to recollect the various acids, just remember one, that is the acetic acid, has 2 carbon atoms, and you can just do the others. So propanoic acid has to get converted to 2-bromopropanoic acid, and this is a halogenation reaction, which is a substitution reaction at the hydrocarbon part. And this is obviously from aldehydes, ketones, and carboxylic acids. And there's a named reaction that is Helmholtz-Zielinski reaction. So I'm going to put the general reaction over here, which is R CH2 COOH is reacting in the presence of a halogen, X2, and red phosphorus. And also water to give us our CHCOOH X. So you have, and X can be Cl or Br. So we have this particular reaction. It's pretty straightforward. And if you would like help with named reactions, I've done a series just on named reactions. So you can go check that out. So here the R group is the CH3. So I'm just going to substitute that over here. So CH3, CH2, COOH reacts with, since it's X2, in this case, it's going to be Br2 and a red phosphorus and water, obviously, to give us CH3, CH, COOH, Br. And this is just a direct, we just had to, you would have had to recollect this particular reaction and just used it for this particular question. The next one, 2, is okay, benzoyl chloride to benzaldehyde. I'm pretty sure this is also easy. If you can figure this one out, you should just pause the video and try it. Okay, so what we want is, we want to convert benzoyl chloride to benzaldehyde. This is the basic thing that we want to do. So how do we do it? Basically, this is a preparation of aldehyde from the acyl chloride, and it's also the Rosenmund's reduction. So it's one of the methods of preparation of aldehydes, and it's in the chapter aldehydes, ketones, and carboxylic acid. So it's a basic, which is going to use that reaction. So you have an acyl chloride, or rather an aryl chloride, or benzoyl chloride, and this is undergoing a chemical reaction. Actually, it's a chemical reaction, BaSO4, to give us CHO. So these are pretty straightforward reactions where we just had to use the ones from the textbook and get the answer. The next question over here. So I'm not talking about the distinguishing benzaldehyde and acetaldehyde. Maybe if you want it, you can let me know and I will upload a new video for that. The next one is this: complete the following sequence of reactions. So to, sorry. Okay, so like the previous video, what I'm going to do is I'm going to take each and every reaction step by step and then do, solve it and then figure the answer out. So the first one is CH3COCH3 is reacting with barium hydroxide to give us something called A. And which, okay, the reason we're continuing with the next step and going forward to B is because it's a named reaction. These are two steps of a named reaction, that is aldol condensation. So I'm just going to say or, make it easy for you to know. And this is A. So CH3CO CH3 is reacting in the presence of barium hydroxide to give us an aldol product. And if you find this particular reaction slightly difficult, I suggest you can check out the YouTube video I made about aldol and cross-aldol condensation. And I explained the entire process in detail and gave few tips and tricks to solve this particular type of equations. And I hope that helps too. So you have CH2CO CH3. This is going to be the product. Again, if you knew how the aldol condensation worked, it would make sense for you to, basically, okay, I'm just going to quickly write it over here. The oxygen of one of these two gets used up and it forms OH. The hydrogen gets shifted from one of this to this, and this forms a bond with this, basically. So that's all it is to it. So yeah. First of all, I would like to change this. Okay. So when you have an aldol condensation reaction taking place, what's happening is you have a new bond formed between this carbon atom and, let's say, this carbon atom. So there's a new bond formed. Okay. And this bond shifts up and the hydrogen from this carbon gets transferred to this. Okay. And the product that we're going to get is CH3, C, CH3, OH, CH2, that is this one, this carbon, and CO, CH3. The next step is elimination of water on heating. And here what happens is this OH gets removed and one of the hydrogen atoms from this carbon gets removed and we get a double bond. So that is CH3, CH3, C, CH3, double bond, CH, CO, CH3. Again, aldol condensation, sometimes even I, for like, if you ask me all of a sudden, it would take me a minute to recollect. So it's a lot. So this is undergoing a chemical reaction with NaOH and I2, and this gives us two products, C and D. So NaOH plus I2. And these are the reagents. NaOX, that is NaO with a halogen atom, is a reagent for the iodoform test. So NaOI is formed when these two combine, and this is essentially the iodoform test. And this molecule would give us a positive iodoform test because of the fact that you have a methyl group beside the CO group. So let's quickly write the general reaction, or the general chemical reaction for the iodoform test, which is RCO CH3 plus, or rather reacts in the presence of NaOX to give us RCO ONA plus CHX3. So this is the iodoform test. And when we substitute this equation, or this particular molecule in this equation, you would get CH3, one of the products, as CH3, C, CH3, double bond, CH, CO, ONA plus CHI3. So with that, we're done with this particular paper. I hope this helps. Do check out the other one where I did for 2020 set 1. And there are a couple of videos where I talk just about the various named chemical reactions that you have in 12th grade. I hope you enjoyed the video.